My name is Mariano Martinez Peck, and okay, I work as a software engineer for instantiations, and I will now talk about how to make your deployment better, increase availability and scalability with Docker. And so you may not remember me, you may not remember my talks, but what everybody remembers is this T-shirt. You know, it's Adrian took that picture for me like 10 years ago. So, you know, Adrian, here I am. You can take the new one. I promised that for a lot of folks, so I needed to win. Okay. Before starting to talk about Docker, we need to understand the lower technology that Docker uses, which is based on Linux containers. Linux containers is not something new. It's something that has been around for a couple of years already. It's a different way of virtualization than the one that you normally use, like VMware or VirtualBox, where the virtualization is that you run a whole operation system in a virtualized way. Linux containers are much more lightweight in the sense that you only run isolated, small container where you can run one or more processes, and you only prepare that container with certain libraries, and that containers, or all of the containers, share the resources provided by the host operation system. Then Docker come in and he said, oh, I have an idea. I want to call it this an image. And so what they did is basically what we all know for 40 years so far. Basically, they provided a way so that you could, let's say, describe how you would like to build a Docker image, make that a binary piece of something, and then you could take that and run it on a container. So for us, it's the same concept. It's an image, in which case, instead of the Smalltalk VM, you have Docker, the Docker engine. So that's basically an image in the world of Docker. But Docker is not just that. They also brought a lot of tools, features. It's really nice. So it's not just that. So why I believe Docker is relevant for the Smalltalk community, or in other words, why I'm here. I think it eases the deployment a lot. I've been working more than 10 years on deploying Smalltalk systems, and it's easy with Smalltalk, much easier than others. But still, with Docker, I think I can make things much easier of certain things that I was doing by hand previously. So I think it's cool. The other thing that it helps us to leverage all the different environments, you know, development, testing, production, etc. So that thing of in my machine it works. Well, with Docker, it can help you more in that process. Like, okay, in your machine didn't work, in the server it did. It's much easier to have a reproducible process for building images and to leverage all the different setups. I think it optimizes the hardware much better than classical virtualization, and so that you can get more benefit from the same hardware. It allows us to do infrastructure as code, which is something very fancy these days in the DevOps world. I prefer to call it infrastructure as config files, but that's what they do. So we can have a part of an infrastructure written in configuration files. So you can version that, and those start to be artifacts and part of your project, which is nice and allows you to have reproducible process. So I think those are really good things. And finally, that there are some big players behind that. So Docker itself, it's a company which grew a lot recently, but for example, there are similar technologies like Kubernetes, which is developed by Google. It's OpenShift, which is developed by Red Hat, and so on. So it's really a technology that is being supported by big players. Okay, so how to Dockerize a Smalltalk application? Right, that's the question. My whole purpose of this demo is to show you that as people think that we are using an old 40-year system, that doesn't mean that we cannot use up-to-date technologies. We can, and that's what I want to show. Okay? Okay, so the demo I will presenting is all on GitHub. You will see under VA Smalltalk GitHub repository. I will show exactly what is on GitHub. So you can completely reproduce it at home if you want. Okay, so let's go to it. So for this purpose of this demo, I will showing a simple web application. If you went to my IoT talk, you already saw this. It's one demo that I'm using everywhere, like my T-shirt. So you can basically click on the lights and, something simple. It's a demo. This is running, in this case, on my development VA Smalltalk image. You see the CSI adapter running here. So I showed yesterday how we can make a production image out of this one. I can't show that now because it's too long, but I showed it yesterday. So with VA Smalltalk tools, we can make a production image for Unix, for example, which is what I will show now, of about 3 megabytes and a half or so. I have already packaged this, so when you continue with the example, you will see a Smalltalk image that contains this example, which I have previously already prepared. So this is the web application. To run it in Docker, I could have used my machine, my Mac, but that was boring. And I wanted to make a cluster where you don't only run containers on one node, but on many nodes. And using two computers was not fun. So I brought these two guys. This is one board, which is called Rock64, which is really cool. It has 4 gigs, 4 ARM cores. It's about $50. And this is a typical Raspberry Pi 3, okay? So each of them are running Docker. So I will run in Docker, not on my machine, but in these devices, and we will run containers there, and then we will finally make a cluster. Okay? Sounds clear? Cool. Okay, so to get started, let me go back to my terminal. So can you all read, even in the back? Can you read the shell? Okay, cool. Thank you. So on the left side, where I am typing, it's the Rock64 here. For the moment, we'll just focus on this one, okay? So for the moment, I will just use a whole terminal for this. So the very first Docker command you can start with is Docker run hello world. No, that's what you normally do. Okay? So when I run this, say, unable to find image locally, you see? And then it went to look for it in internet, downloaded the image, and then that output you see on the console is what that image is supposed to do. So that thing, hello from Docker, this message shows that your installation appears to be working. So that's what that hello world image does. I didn't have this image on my machine. I didn't have the Docker image in here. So there is this place which is called Docker Hub, where it's a big repository which is on internet, and there are plenty of already prepared images that you can use for anything, for databases, for regular operation systems, web servers, whatever. So there are, I don't know how many, but thousands, millions, I don't know. This is a global repository. So in that case, Docker was smart enough and I said, okay, I don't have this image. I will look, download it, and run. Okay? Then you can see some Docker information. So I can do Docker info and say how many containers I have, how many images. I can do Docker image ls. Something is very cool about the Docker command line is that it's quite similar to regular Unix command line. So it uses ls, ps, logs, and all the commands that you are used to. So it's very nice. So you can see there all of the Docker images that I have in this machine. And this is the hello world that it was just downloaded. Then I wanted to show you the example. So you can see this is a perfectly clone of repository I previously showed. So if I do git remote, you can see it's a clone of the example that is on GitHub. And just to show you, I did not hack or did any trick. I don't have anything dirty. I don't have untracked changes. And the last thing I wanted to say is that, look at this. So we are on ARM64. So here I have an Armbian ARM64 bits running. And here on the Raspberry Pi, I have Ubuntu server ARM64. So both are ARM64, and we will be running VA Smalltalk ARM64 bits as well, which I think it's also very interesting because many boards are coming now with ARM64 bit only operation system, as I will show in the afternoon with the NVIDIA Jetson Nano. Okay, so that's the basic for Docker. So now we will see how to Dockerize our Smalltalk application. Okay? So the most important file for making a Docker image is what is called Docker file, where you spec all for that image. So for the most one important line is the first one, which says from where you are starting that image, because the idea is that you don't build an image out from the scratch. You start from already existing images, which can be images of your own or image that someone put it on Docker Hub. So in this case, for example, I am starting from Debian version 9, and this variation, which is called Slim, which is a very small Debian distribution. And something very important is that when I build this image and I run it, I will always be running Debian. It doesn't matter what's the host. Here I am running Ubuntu. Here I am running, here I'm running Armbian. Here Ubuntu. On my machine I'm running Mac. And it will always have the same effect. It's a reproducible image, the Docker image. It doesn't matter from where you start from. As long as you have a Docker engine able to run images, you are done. And that's part of why it's reproducible. Sometimes people, when you're starting, it confuses this because you're still thinking on your host operation system, but it's nothing to do. They are two completely different stories. Okay, so then you specify some metadata, a version, maintainer, description, whatever. In my case, I need to install VA Smalltalk dependencies. So it's just libc. We need OpenSSL for CSI, locals, and core. And then I just do some cleanup, generate the locales, and that's all. So that's all my dependencies I need for running this Smalltalk application. Then there is this is a little bit more advanced, but this is a health check, which is very cool. So it goes every 1 minute, checking if my CSI adapter in the image is alive, and if not, it kills it. So that way, I can auto restart containers if for whatever reason the CSI adapter stops responding. So that's nice. And then I finally said, I can tell to the image which will be your working dir. I mean, when you start, where you be starting. So you need a starting working directory. So I say, okay, I want to start in opt/app. And then I copy 2 directories from my host machine into the image. So the 2 directories I will be copying is the bast92 and app. You can see I'm using dot here, so that means they are on the same level as this file. So if you see here on the right, I have these 2 folders, which I will show you later on the pie, how they look like. But basically, I am just copying over those 2 directories into the image. Then make some directory, expose the port that CSI will be using. And finally, I say, okay, run this command. You need to specify a command for Docker to run. And here I'm saying my specific bash script, which starts, I can show you what that looks like. Here it is. You see, it's nothing strange, some variables that we need to export. And then this is the critical line where I just execute the VA Smalltalk virtual machine headless, and I specify which Smalltalk image to run and the ini file. And that will start. My image. And when I build the image, I put that at startup, it should start my CSI server. Okay? Okay, so once you have specified all the Docker file, you now need to build the image. Okay? So let's do that. So I will come here, and I will, no, not run. Build. So what I am saying here it's Docker build /f, and I specify which file, and then I give it a name, which is a name for the image. In this case, I call it CSI Debian Slim. So you can see here all the steps he needed to do to build this image. Normally, this takes several minutes, and I don't have the time to show this. Basically, it will detect that this image doesn't exist on my system. It will go to Docker Hub. It would download a Debian image. It will install the dependencies. Then it will generate the locales. It would do everything that I specify until the image is built. But that takes like 10 minutes or 15 minutes. So I needed to have this pre-built. So if you see Docker image ls, I already have built that image, since 13 days ago. But if you want to see this offline, contact me and I show you. I remove the image and I show you. We will need a good internet, but I can show you. So far, so good. Okay. We built the image. Next step is to run it. So I will run the image with this command, which basically says docker run, and I can specify here some environment variables. Then I mount some directory, which it's something, a detail which I don't want to get into there now. I export the port that we are using for CSI. Finally, the name of the image that we want to run, which was the image that we just created before. Okay, so when you run, you see it started to run VA Smalltalk, and then it started to start CSI. So now if I check my browser, and I go to this machine, which is Rock64 at the port 777, you see that the application is running, and now it's running inside a container on this device. I can show you, for example, if I open another terminal and I connect to the machine, you do Docker container PS, and you can see we have one container running with this ID, which is running this image with this command, the port, and blah, blah, blah. So you see that the container is running. And if I now click on the green light generates an error on purpose because I wanted to demonstrate many debugging abilities. So I will click here, and this will stop the Smalltalk image, and hence the container will stop. So you can see here there was an error, and we dump the binary stack into a file for future debugging. If you check now again the containers, now you will see there is none because the container was dead. Okay, so yes.
Configuration?
Good question. I will show you. This was the bash. Okay, so for showing this error with CSI, I hook a specific error handler that would do nothing on purpose and pass through deception. So that way I am not handling deception and CSI, and it's reaching up to the very top of the VA Smalltalk handler, which eventually closes the image and dumps, a wallback or whatever. So I'm doing that on purpose. So that will stop this line. Then Docker will continue with the bash, which will come to here, which I do this on purpose. So when I quit the image, I want to back up the logs. So I copy the logs. And whenever the shell finishes, the container finishes.
Ah, I see. So this is not the health check from Docker?
Exactly. The health check is only if the container is alive, but your adapter is not responsive, which I know you saw that before.
Yes, I still do,
Yeah.
by the way.
Okay. So far, we saw how to build a Docker image to run a Smalltalk application. But the interesting idea is to make a cluster. So you don't want just one node, you want many nodes running 10 or 100,000 number of containers. So Docker provides this tool, which is called Docker Swarm, which allows you to build a cluster of whatever number of nodes and whatever number of containers. And so that's what I will show now. Okay? So let's back to my terminal. Okay, let's close this one. Okay. So the most important file for when you're gonna do a Docker Swarm, like previously it was the Docker file to specify an image. For a swarm, the most important file is It's called DockerCompose. So here it's exactly that. You are composing services. So I define two services here, one that I call CSI, and the other one which I call balancer. Okay? To the service that I call CSI, I say, okay, use this image, which is the one that we just built, and the one that we just run one container. I specify some environments variables, and then I say, when you deploy 10 replicas. Okay, that means 10 containers for that image. Okay, this is a really small number because the Smalltalk image file, it was just 3 megabytes, and this guy has 4 gigs, so I could perfectly run, I don't know, I didn't test, but for sure much more than 10. But for the example, it's okay. And then I specify some settings for the balancer. I am saying like, okay, I want to use this port. This is my rewrite rule. You know, typically when you are using a web server as a reverse proxy, you need to specify the rewrite rules so that the external web server knows how to redirect requests to your Smalltalk server. So here's how you do it with traffic, which is this web server that I am using for this demo. And the last thing is that we need to tell traffic that our session needs to be sticky because CSI is stateful, so we need a session affinity. And then I define another services, which I call balancer. And notice that here I am saying, okay, use this image, which is traffic 1.7. And this image is not mine. I don't have it locally. So this is on Docker Hub. So traffic, it's a web server that they have images on Docker Hub, and all I need to do to use it is just say, okay, I want that image, and that's all. Docker will take care of downloading it automatically from Docker Hub. And then I have some constraint. I'm telling, run this only on the manager, because I want, you don't want to run multiple balancers, or maybe yes, but that's more advanced setup. In the case, I just want to run one balancer, and that's why I didn't put replicas. And I said that I want to run it in the manager of the cluster. So we will see later that when you create a cluster, you normally have one manager and many workers. You can have more manager, but it's more complicated. And then some command lines, arguments, whatever I need to specify to traffic. I'm telling him to open the port 80. So the external web server will be listening on 80. And then some details which I don't care to show. Okay?
Yes, I have a small question about replicas. You said that Smalltalk image is just a few megabytes, but the Docker container is 100 megabytes. Does it mean when you have replicas, it's using the same 100 megabytes memory of the container?
Exactly. Yes.
Okay.
Yes. Good question. Yes. The only thing is that 100, it was the size of the image.
I think so.
Yeah, I think it got bigger with the latest Debian. Yeah, that's true. With the previous Debian, it was about 60. I don't know why it's.
Okay, but in the end, the same image with the replicas, only the size only increased by your application size.
Well, yes, but you can also make, you could also have a web Smalltalk application that uses a lot of RAM and a lot of memory, so that will fail too. What I was trying to say in the general is that on a regular small or medium size, you can run more. I mean, but it depends what the application does, etc. But it was just an example that for this demo on this device, I could run, I don't know, 100 probably.
Okay, thank you.
But yeah, thank you for the input. Okay, so the last thing, that is how you compose services to make a Docker Swarm. And the last bit is that for starting this, you need to use this command, which is docker stack deploy, and you specify the DockerCompose and the name that you want to give, and then to stop, you do this. To avoid doing that, I already have bash scripts that start and stop the swarm. So I will use those for the demo, but this is how you would normally start and stop this swarm. Okay, so now I am on the manager, which is this one, and I will say Docker swarm init. Okay, so he said now Docker swarm initialize current is now a manager. So as I initialize the swarm, I am by default the manager. So this guy will be the manager, and here you see to add a worker to this swarm, run the following command, and it gives you this line to run. And if you can see the IP there, the port, etc. So you can add workers from anywhere. Okay, so if you now see Docker node ls, you will see I have only one node for the moment, which is just me. But now I will take this and I will run it on Ubuntu. That is on the Pi 3 that is there. So, okay, this node joined as a worker. Okay. So now if I do Docker node ls, you can see, okay, we are two guys now. You can see some status there. You can see here's the leader. So the Rock64 is the manager. Sorry? Yes.
I just wanted to see the replicas if there's
Yes,
10.
that's where I'm going now.
Okay.
So because so far I didn't start the swarm. The only thing I did is set up the cluster and say, okay, you guys, you know you're a cluster. But so far I didn't start. It's what I'm doing exactly right now. And there, as he just asked, this is starting the swarm. So this will start the balancer containers and all our 10 C-side replicas. So the balancer should have been run on the manager. On the other 10 C-side replicas, since we didn't specify, they should have been split between all of the nodes of the cluster. Since I have two devices, two nodes, should have been split between those two. So you can do, before the commands were Docker something, when you are using a swarm, you need to do Docker service. So you have Docker service ls, for example, and here you can see the balancer has already started. You see, I only say one replica, and it has already started. So 1 of 1. The image, it was traffic, and it's listening on port 80. The C-side one, I wanted 10 replicas. 5 were started so far, and this was the image that we used for that. So if we wait a little bit, which I think we have already waited, you see, okay, now the 10 were already started. So now if I do Docker service PS and I specify which service, you can see, you can see the 10 replicas. We have 10 containers running, and they were all split between Ubuntu and the Rock64. In fact, 5 and 5. So he took the 10 replicas and distributed over the nodes that I had. In this case, I could have made 5 nodes, but it was too much to set up. But you can see that it really, well, to see it working, I actually should go, because otherwise, if I go to now Rock64 and I enter on port 80, I should get this working. And who listened to that request? I don't know. Which node? I don't know. Which container? I don't know. Someone. We could be anyone on the cluster. Something very cool is, for example, if I click on the green button, which I show you what happens, it shut down the container. And we'll wait, I don't know, 1 second, I guess. You saw what's happened. So the lucky guy was the number 6, that here to my request. And when I kill it, you see now that it's shut down. You see here? It's shut down. And Docker automatically started another container to satisfy the 10 replicas I told him. Okay, so that's pretty cool. In fact, I can do this as well. So I am now on the Raspberry, and I will turn it off. I shut it down. So what will happen? What do you think will happen? Yeah, automatically. Yeah. Start 10 more replicas, 5 more replicas to satisfy what I said, that I wanted 10 replicas. And of course, here it would only have 1 node left to where to go. But if you have 500 cluster, it would split between all of the remaining clusters, not just to the manager. Yes?
So what will happen if you restart the Raspberry Pi and re-register the node in the swarm? Will it again?
No, but that's on purpose. So if you see now Docker node ls, you can see the status here, it's down. You see on this node, but it's still active as availability. So that means that node is still part of the swarm, but currently it's down. Okay? If you restart this, it won't put back the containers over the other node. I think it's on purpose because it assumes that you probably want to check health of your operation system, your data, or whatever. Maybe there's a config file, some setting to change that behavior. I don't know. But the default behavior is not. In fact, let me show this last thing. Okay, so you can see now all the ones that were dead, this one, this one, this one, this one, and now the alive are all on the Rock64. Yes.
How do you see the debugging process in
Docker Docker service logs.
Yeah, you have the logs. I saw you have the logs.
Yes, for example, Docker service logs, and you pass the container ID. You can see the std out and std error, for example. Another thing which is very interesting for debugging is to open an interactive shell on the container. So if you allow me 1 more minute, I can show that. It's pretty cool. I wasn't too sure because...
One more question. How many logs will you have in the end? Perhaps if you have launched, I don't know, say N containers,
Yes.
you will have potentially N logs.
Yes.
So
Yes,
my question is, how
Yes.
do you manage that?
Yes, the normal acceptance in the DevOps or container world is that normally you use a third-party provider for the logs, where you don't store them locally, like I am using in this demo. You have a third-party provider, you know, that they give you a fancy dashboard. They have an API that you can normally go over REST. And from your application, you push your logs into that place, and then you have a nice dashboard where you can. But yeah, and the same goes for files. For example, when a container dies, everything that you have written on the container is left. So people use, you know, this Amazon file storage. So that's the most common approach, because you may have 100 containers, everybody login. So that's what people normally do. I think I have, yeah. This is the last thing I want to show. It was out of my slide, but okay. So you can run a container indirectly. You mean you see the -/IT? So now I am running a container. I'm telling run bash on that container. So here I am inside. Oops.
Okay,
So-
so I'm very sorry, but
Okay,
I'm going to have to ask you to conclude.
that's all.